Dear friends, in this video, we learn necessary and sufficient condition for union of two subspaces of a vector space is again a subspace. The necessary and sufficient condition for union of two subspace is a subspace of a vector space is given by the union of two subspaces is again a subspace of a vector space if and only if one is a subset of other. And we are now see the proof of this theorem. Let V be a vector space over R and W1 and W2 be two subspaces of V. So considering the two subspaces of V, when their union is a subspace if and only if one is a subset of other, that is one is contained in other. So we are consider the two subspaces W1 and W2 of a vector space V. So we are now going to prove the direct part of this theorem. Suppose that the union W1 union W2 is a subspace of V, we are going to prove that either W1 is contained in W2 or W2 is contained in W1. That is, W1 is a subset of W2 or W2 is a subset of W1. So assume the contrary, that W1 is not contained in W2, W1 is not contained in W2 and W2 is not contained in W1. So what happens? W1 is not contained in W2 means what? There exists at least one element X such that X belongs to W1 but X does not belongs to W2. And since this W2 is not contained in W1, there exists at least one element Y in phi such that Y belongs to W2 but Y does not belongs to W1. So X belongs to W1 means what? X belongs to W1 union W2, that is X either belongs to W1 or belongs to W1. Since X belongs to W1, X belongs to W1 union W2. Similarly, Y belongs to W2, Y belongs to this union, and this union is a subspace, so it is closed under addition. That is, the sum X plus Y must belongs to W1 union W2. Therefore, either X plus Y belongs to W1 or X plus Y belongs to W2. We will see what happens if X plus Y belongs to W1. So suppose that X plus Y belongs to W1. Then since W1 is a subspace, X plus Y minus X belongs to W1. Because X plus Y belongs to W1, X belongs to W1. Since W1 is a subspace, minus X also belongs to W1. So X plus Y minus X, that is Y belongs to W1. This contradicts that Y does not belongs to W1. Why this is contradiction? Because we have assumed that Y not belongs to W1, but we reach that Y belongs to W1. This contradicts that Y belongs to. Similarly, if this X plus Y belongs to W2, then since again W2 is a subspace, X plus Y minus Y belongs to W2, that is X belongs to W2. Because X plus Y belongs to W2, Y belongs to W2, minus Y belongs to W2, X plus Y plus minus Y, that is X plus Y minus Y, that is X belongs to W2. This contradicts that X belongs to. In either case, we have reached a contradiction. Therefore, we have either W1 is contained in W2, that is W1 is subset of W2, or W2 is a subset of W1. So converse part. Suppose either W1 is contained in W2 or W2 is contained in W1. That is, if W1 is contained in W2, then what happens? W1 union W2 is W2, because W2 is bigger than W1 and W1 is contained in W2. Union is W2, which is again a subspace, because we have assumed that W2 and W1 are subspaces of vector space. If W2 is contained in W1, then what happens? Union is W1, which is subspace of U. Hence the proof. This is a very simple proof. which gives the necessary and sufficient condition for union of two subspaces of a vector space is again a subspace. Thank you.